Hello everyone, in this video we are going to talk about ratio and proportion. Let's begin by taking a few examples. Suppose the height of Anika is 120 centimeters and the height of Arushi is 140 centimeters. So how do we compare their heights? One way is that we subtract the height of Anika from the height of Arushi, that is 140 minus 120, which gives us 20 centimeters. So we say that Arushi is 20 centimeters taller than Anika. The other way is we divide the height of Arushi with that of Anika, that is 140 upon 120, which comes out to be 7 by 6 in the lowest form. So we say that Arushi's height is 7 by 6 times the height of Anika. The first method is called comparison by difference and the second method is called comparison by division. Let's take another example. For making a cake for 6 servings, we need 2 cups of flour and 1 cup of milk, of course along with other ingredients also. So for making a bigger cake, if I use 4 cups of flour, how much milk should I use? Should it be 2 cups or 3 cups? The correct answer is 2 cups. In this case, the amount of flour is increased by 2 cups, but the amount of milk is increased by just 1 cup. So we see that there are certain situations where comparison by division makes more sense than comparison by difference. Let's take another example. Two people start a business, Aman and Naman. Aman invests $200 while Naman invests $400. At the end of 1 year, they both earn a profit of $1,200. So now what should be the share of each person? Should the profit be equally distributed between the two earners? That is $600 each? Or should the share have a difference of 200 between them? That is $500 for Aman and $700 for Naman. Neither of these options is correct. Aman would actually get $400 and Naman would get $800. Further in this presentation, we'll see how this happens and how the profit is actually distributed among both the investors. So there are certain situations where comparison by diffusion makes more sense than comparison by difference. This comparison by division is known as ratio. It tells us how many times one quantity is of the other. It is denoted by a colon and is read as is to. Let's have a relook at the few examples that we have already seen. The first one is comparison of height. The height of Anika is 120 centimeters and the height of Arushi is 140 centimeters. How do we compare them by division? We have the height of Arushi in the numerator and the height of Anika in the denominator, that is 140 upon 120, which reduces to 7 upon 6. 7 is called antecedent and 6 is called consequent. So we say that the ratio of Arushi's height to Anika's height is 7:6. Let's see the reverse of this. The height of Anika is in the numerator and height of Arushi is in the denominator. So the fraction becomes 120 upon 140, which is 6 upon 7 in the lowest form. So we say that the ratio of Anika's height to Arushi's height is 6:7. So what do we see here? The order is very important. What we take in the numerator and what we take in the denominator. So we need to be very careful when we are calculating ratios. Let's relook at the cake recipe again. The flour and the milk, they are needed in the ratio 2 cups is to 1 cup. If 4 cups of flour is needed, we need 2 cups of milk. That means the ratio of flour to milk is 4:2, which reduces to 2:1. So the actual ratio becomes 2:1. The next example, investment of Aman is $200 and investment of Naman is $400. So their investment is in the ratio 200/400, which reduces to 1/2. So we say the ratio is 1:2. So ratio is a fraction reduced to lowest form. Let's take another example. Suppose the number of boys in grade 6 is 15 and the number of girls is 20. So what is the ratio of boys to girls? See the order here. It is boys to girls and not girls to boys. So in the numerator we'll have the count for the number of boys, and in the denominator we'll have the count for the number of girls. Now we reduce 15/20 to the lowest form, so it becomes 3/4. So we say the ratio of boys to girls here is 3:4. Another example. Suppose one of the students in the class gets 69 marks in science and 92 marks in mathematics. So what is the ratio of the marks in science to mathematics? 69/92. And when we reduce this to lowest form, it comes out to be 3/4, that is 3:4. So what do we see? There are different situations that may have same ratios. In both these situations, the ratio is 3:4. When comparing using division, the unit for the quantities being compared should be same. Let's see now. 2 kilometers to 500 meters. How we find the ratio? First, we convert 2 kilometers to meters, that is we multiply by 1000 so that we get 2000 meters. And then we find the ratio of 2000/500. So on reducing to lowest form, it becomes 4/1. So we say the ratio is 4:1. Let's take another example. 7 hours to 30 minutes. We convert 7 hours to minutes, that is 7 into 60 becomes 420 minutes. It is always easier to convert from a bigger unit to a smaller unit. And then we find the ratio. It becomes 420/30. On reducing to lowest form, it becomes 14/1. So the ratio is 14:1. So the quantities being compared should always have the same unit, and ratio itself does not have any unit. Another very important example. The cost of 2 kg of apples is $20 and the cost of 5 kg of oranges is $15. So what is the ratio of the cost of apples to oranges? Is it 20/15? On reducing to lowest form, 4/3, that is 4:3. This is absolutely incorrect. So how do we proceed in such cases? We first find the cost of 1 unit, that is 1 kilograms of apples and oranges. So what is the cost of 1 kg of apples? We divide $20 by 2. We get the cost of 1 kg apples as $10. The cost of 1 kg oranges is $15 divided by 5, which comes out to be $3. Now we finally find the ratio of the cost of apples to the cost of oranges. So this becomes 10/3. There's no common factor, so it is already in the lowest form. So the ratio of the cost of apples to oranges in this case is 10:3. So we need to be very careful about the unit when finding ratios. The unit of the quantities being compared should be same, whether it is cost, length, speed, or duration, or even anything else. How do we compare two ratios? Which ratio is bigger, 4:8 or 3:9? 4:8 can be written as 4/8. 3:9 can be written as 3/9. So we use cross multiplication to find which of these ratios is greater. We first move the denominator of the second ratio up along with the numerator of the first ratio. So the left side becomes 4 multiplied by 9, and then we bring the denominator of the first ratio to the numerator of the second ratio. So on the right side we get 3 multiplied by 8. On evaluating, it becomes 36 on the left side and 24 on the right side. Out of 36 and 24, which is greater? 36. So we say that 4:8 is greater than 3:9. Let's take another example. 2:4 and 3:6. We need to find out which of these ratios is greater. 2:4 is 2/4 and 3:6 is 3/6. Again we bring 6 to the upper side along with 2 on the left side, so it becomes 2 cross 6. Then we bring 4 to the right side along with 3, so it becomes 3 cross 4. Both left side and right side evaluates to 12. So we say that the ratios are equal. 2:4 is equal to 3:6. So we see that the ratios can be compared using greater than, smaller than, or an equal to sign. Now what are equivalent ratios? Multiplying or dividing the numerator and denominator by the same number gives us equivalent ratios. Let's understand this by taking an example. 4:3. It can be written as 4/3. On multiplying both numerator and denominator by 2, we get an equivalent ratio 8/6, that is 8:6. If we multiply the numerator and denominator by 3, we get 12/9, which is another equivalent ratio of 4:3. So for any given ratio, we can find infinite number of equivalent ratios by multiplying both the numerator and denominator by the same number. Let's take another example. 24:36. This is written as 24/36. If we divide both numerator and denominator by 2 in this case, we get 12/18, which is an equivalent ratio of 24:36. If we divide both numerator and denominator by 3, again we get another equivalent ratio, that is 8/12. And if we divide both of them by 6, we get another equivalent ratio, 4/6, that is 4:6. So both division and multiplication can be used to generate as many equivalent ratios as needed. Thus, the ratios with the same lowest form are called equivalent ratios. Now, what is proportion? Suppose you see a flag post and a tree. The height of the flag post is 25 meters and the height of the tree is 15 meters. You found them very interesting and you want to draw them on a sheet of paper. So on a sheet of paper, you draw a flag with a height of 10 centimeters. Now, what should be the height of the tree on the drawing sheet? Actual height of the flag and the tree differ by 10 meters. So on the sheet, should they also differ by 10 meters? No, certainly it's not possible. So what should be the height of the tree in the painting? Let's see. When we find the ratio of the actual height of the flag post to the height in the painting, we get 2500 centimeters upon 10 centimeters. So we need to be very careful with the unit when calculating ratios. We have converted 25 meters to 2500 centimeters for calculating the ratio. So the ratio becomes 250 upon 1, that is 250 to 1. Now the ratio of the actual height of tree and the height of the tree in the painting would be 1500 centimeters upon x centimeters, which should be equal to the ratio of the height of the flag post, that is 250 upon 1. On solving this linear equation, we get the value of x as 6 centimeters. So we say that the height of the tree should be in proportion to the actual height of the tree. Thus, equality of two ratios is called proportion. When we equate the ratio of the height of the flagpost to the height of the tree, we say that our painting is in proportion to their actual heights. So, if two ratios are equal, they are said to be in proportion. That is, the lowest form of the first ratio is equal to the lowest form of the second ratio. Then the two ratios are said to be in proportion. For example, 14 upon 12 and 21 upon 18. What is the lowest form of 14 upon 12? It's 7 upon 6. And 21 upon 18, again the lowest form is 7 upon 6. So we say that the two ratios 14 upon 12 and 21 upon 18 are in proportion. Proportion is denoted by two colons and read as is as. 14 is to 12 is as 21 is to 18. So how do we check whether the four given numbers are in proportion or not? For example, 12 is to 24 is as 2 is to 4. The second and the third term are known as mean terms, and the first and the fourth term are known as extreme terms. There are two ways of finding whether these numbers are in proportion or not. The first method is ratio of the first two numbers is equal to the ratio of the next two numbers. If this is true, then the four numbers are in proportion. In the above example, the first two numbers make up a ratio of 12 upon 24, that is 1 upon 2. The last two numbers are 2 upon 4, that is again 1 upon 2. So we say that these four numbers are in proportion. The other way of finding whether the given numbers are in proportion or not is that the product of mean terms is equal to the product of the extreme terms. In the above example, the mean terms are 24 and 2 and the product is 48. The extreme terms are 12 and 4 and the product is also 48. So we say that the four numbers are in proportion when the product of mean terms is equal to the product of the extreme terms. Now what is continued proportion? How can we check whether three numbers are in proportion? The middle term is repeated. For example, 16, 12 and 9. How do we check? We repeat the middle term and make it 16, 12, 12 and 9. Now we can use any of the two methods to find whether these four numbers are in proportion. That is, ratio of the first two numbers is 16 upon 12, which is 4 by 3 in the lowest form. Ratio of the next two numbers, that is 12 upon 9, is again 4 by 3 in the lowest form. So we can say that the three numbers 16, 12 and 9 are in continued proportion. The other method is product of mean terms is equal to the product of extreme terms. That is 12 cross 12, the product of mean terms is 144 and the product of extreme terms is 16 cross 9, again it is 144. So the square of the middle term is equal to the product of the extreme terms when we have to check if three numbers are in continued proportion. For interesting articles, you can visit the website www.masciacademy.com. For any queries, you can send an email to masci.academy@gmail.com. For more such videos, subscribe to the YouTube channel. And if you like the video, don't forget to click the like button.